Hello class, let's start with part 7 now. In this part, we're going to talk about transducers and thermistors. What are transducers? Transducers are electrical or electronic devices or components that changes one form of energy into another form of energy. These devices respond to physical quantities like temperature and light. They act as the interface between the environment and the electronic system. So transducers allow circuits to interact with the outside world. So that means they take something from the outside world and turn it into electrical signals or data, or they use electrical signals or data and produce it in the outside world. So these are widely used in control systems, electrical and electronic instruments, and electronic communications. There are two types of transducers. Transducers that convert non-electrical energy into electrical energy are called input transducers. So these are things that the circuit take from the outside world into the circuit, into electric signals or into data. So that's why they are called input. Okay, so they take in signals from outside. These are thermistors. So thermistors take in temperature and change it into electrical signals. Microphones, they take sound waves into electrical signals. Light dependent resistors, they take light energy into electrical energy. Pressure sensors takes pressure. So anything that goes into the circuit. And then the second type of transducer is what we call an output transducer. So an output transducer is when something that's in the electrical circuit is being produced out to the surrounding or to the outside world. So that's why it's called output. And these are examples. So loudspeakers, it's basically electrical signals changing into sound waves. Lamps, electricity changing into light energy. Light emitting diodes is basically the same as lamps. Voltmeters, it uses electric signals and then moves the needle of the voltmeter to show you how much voltage there is. And the same thing goes for ammeters. Okay, so those are basically transducers. So in this chapter and also in the next chapter, we're going to talk about some of these transducers. Mainly, we're going to talk about thermistors, light emitting diodes, and yeah, those are basically it. So first, we're going to talk about thermistors. We have talked about them before in the previous topic, so we're going to go through it again. So a thermistor is a device that has a resistance which changes with temperature. So generally, the resistance of a thermistor decreases if the temperature increases. So if you have a temperature that's decreasing, that means the resistance of the thermistor is increasing. That's how it works. So thermistors are used for temperature control and temperature measurement circuits. So typically, we can add thermistors to potential dividers to make a potential divider that depends on temperature, like in this picture here. This is a potential divider circuit because there are two resistors in series, and we can connect a thermistor in the second slot so that we can control the output voltage using temperature through the thermistor. Let's do example 8 to see how a thermistor can affect the output voltage or how the thermistor can control the output voltage of a circuit. So it reads, the circuit below shows a potential divider with a thermistor and a fixed resistor of 100 ohm. Let's write down here. This is 100 ohm. Connected to a 6 volts battery, so the EMF is 6 volts. The table below gives the resistance RTH of the thermistor of temperature 0 degrees Celsius and 100 degrees Celsius. So the thermistor can go from 50 ohm up until 500 ohm. If the temperature is 100 degrees Celsius, the resistance of the thermistor is 50 ohm. If the temperature is 0 degrees Celsius, then the resistance of the thermistor is 500 ohms. Calculate the output voltage across the fixed resistor when the temperature is 0 degrees Celsius and 100 degrees Celsius. So for this one, we're going to use the formula of the potential divider, this one. R1 is the 100 ohm, the fixed resistor, and R2 is the thermistor. So at 0 degrees Celsius, what is the voltage output of this circuit? R1 is 100. R2 is 0 degrees Celsius. That gives us 500 ohm times the EMF, which is 6, and that is 1 volt. And at 100 degrees Celsius, R1 is still the same, and R2 is 50. So this is equal to 4 volts. Okay, so what does this mean? When the temperature is high, when it's very hot, 100 degrees Celsius, this potential divider circuit gives an output voltage of 4 volts. When the temperature is cold, when the temperature is low, this circuit gives a voltage that is low, around 1 volts. B. Calculate the effective resistance of the two resistors in the potential divider when the temperature is 0 degrees Celsius. So R is always fixed, 100 ohm. At 0 degrees Celsius, the thermistor has a resistance of 500 ohm. We know from the table that was shown in the question. So what's the total effective resistance? So this is basically, because they are in series, it's basically just R1 plus R2. So it's 100 plus 500. And the effective resistance or the total resistance is 600 ohm. C. Use your answer in B to calculate the current I at 0 degrees Celsius. Now we want to find out the current. So this is the main current or the total current. So in order to find this, we use the formula R is equal to V over I. But we rearrange this to make I the subject of the formula. So it becomes like this. And because this is the total current or the main current, we use the total of everything. So the total current is equal to the total voltage, otherwise known as the EMF, over the total resistance. So if you want to find the current, the total voltage or the total EMF is given to us, and it is 6. What is the total resistance? The total resistance is 600 ohm. This is what we calculated in B. So 6 over 600, that is 0.01 amps. And that is the answer. Now we do the same thing. For this time, we want to do it for 100 degrees Celsius. So at 100 degrees Celsius, the resistance of the thermistor is at 50 ohm. So the total resistance, again, just add those two together. 100 plus 50 gives us 150 ohm. And if you want to find the current at 100 degrees Celsius, again, we use the same formula as before. Total voltage is 6, that's the EMF. Total resistance is 150, and that will give us a current of 0.04 amps. Okay, so that means when it is hot at 100 degrees Celsius, the current in this resistor is quite high. But when it is cold at 0 degrees Celsius, the current here is not very high, it's 0.1 amps. So that's how this circuit works. Okay, so to summarize part 7, let's look at the learning objectives. You need to be able to give examples of transducers. So the examples are given here. There are 2 types of transducers. The input transducers listed out here. And also you have the output transducers listed out here. Describe what a thermistor does. Basically, when the temperature is high, the resistance is low. When the temperature is low, the resistance is high. So next part, we're going to talk about the other 2 transducers, which are the light dependent resistor and light emitting diode, and that will be in part 8, which is the last topic for this chapter.